Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
Here we have a chemistry problem where we're dealing with solutions and precipitates. In the end, we're going to find out how to do a net ionic equation and a molecular equation, the way the AP chemistry exam would want you to be able to present them. Here's the problem. We've got a sodium sulfide solution, okay, of a solution of an ionic material, and it forms a precipitate with silver ions forming silver sulfide when reacting with silver nitrate solution. Before we go over the formulas and the precipitates and such, let's see what these things really look like. Sodium sulfide solution is a sort of a clear solution. It tends to be a bit stinky though. There's an older name or a compound like it, potassium sulfide, that's called liver of sulfur because it's sort of a yellowish solid before it dissolves. Major use of these soluble sulfides, and this is soluble because it's got a sodium compound, so we can make a clear solution. And this clear solution is typically used with silver. Now here's a pretty little button, and you can see it's got a nice leaf design and these little beads. Well, if you put this silver button in a solution of sodium sulfide, there'll be a reaction. And that reaction will end up producing a black precipitous, that's silver sulfide. Some of that sodium sulfide will react with the existing silver and turn the entire thing black. And if you work with liver of sulfur or sodium sulfide, take your jewelry off and wear some gloves because your jewelry will be stained black. Here's the result. A button now that has, in fact, it would be all this dark color, and then you buff off the highlights and you're left with this beautiful black to show the contrast. Then that's what silver sulfide is used to do. It's used to stain your silver with a permanent black so you can highlight the really shiny parts to it. Next time you see some jewelry that has a patina of black and then its shiny parts, you'll know that they use the soluble sulfide to make it. There's our solution, sodium sulfide. We'll deal with the precipitate later. The silver nitrates, the other substance that you have. Silver nitrate used to be used a lot in chemistry labs, but it's not used much anymore because the price has gone up quite a bit. If you want roughly 3/4 of a tablespoon of silver nitrate crystals, 25 grams, you'll have to pay $80. And if you want to have about a half a mole of that, about 4 tablespoons, you're going to have to spend $284. And if you want enough for a classroom experiment, you're going to have to spend well over $1,000 for this silver nitrate. But of course, it's a nitrate, it dissolves, and it has silver in it. It's made from silver. It's an amazing solution. Here you see the stuff that looks like water, and you've got the equivalent of a silver ring in that solution if you can figure out how to get that silver out. We'll do that later on when we do oxidation reduction. One extra thing you should know about silver nitrate, aside from it being a beautiful clear solution and it's very expensive, is that if you get some on your hands, the silver will end up reacting with your skin to make this black precipitate, which is really finely powdered silver. If you don't wear gloves and you work with silver nitrate, invariably you're going to get this blackish stain, but just realize that stain is finely powdered silver, so you can just show it off. Normally you can't get rid of it until your skin peels off, so you'll have a stain that'll last for about a week. But back to the problem that we have, and that is we have sodium sulfide solution reacting to form solid silver sulfide. Well, let's watch this reaction. Here's the reaction. You can see the clear silver nitrate in the bottom of this test tube, and then they're going to squirt sodium sulfide solution, which again is clear, into it, and look at that, a muddy black precipitate, 2 clear solutions to make a precipitate, the silver sulfide, and our nitrates and sodium will be spectator ions. But now on to the chemistry. We need to do a net ionic equation, and this is pretty typical. They'll say, okay, here's a reaction. Let's find or write the net ionic equation. Well, first you're going to have to find the formula of sodium sulfide. Well, you know your polyatomic ions and your ions, and you should know by now that the sodium alkali metal, all the alkali metals have a +1 charge. Sulfide, like oxygen, it's in the oxygen family, as a -2. So if you're going to have a compound with this, and you're going to write that compound, it's going to have to be neutral, because we're not going to have a charge. That's impossible. So we'll need 2 sodiums for this 1 sulfur. Now, our typical fast way of doing this is we take the number of the anion and bring it down to the cation, the number of the cation and bring it down to the anion, and then reduce the lowest hold ratio. In this solution, you're going to have twice as much sodium as you will have sulfide ions. Silver nitrate. Nitrate's a really, really common ion. There's never been an AP exam without nitrates. We've got our 2 ions. We have our silver with a +1 charge. Silver is used a lot, and you should know that. It's a transition metal, and most transition metals have quite a few possible charges. Silver is an exception with a charge of +1. This is an ion. When it dissolves in water, it's invisible. And then we have our nitrates. And remember, all nitrates are soluble. So if you end up having gold nitrate, you have titanium nitrate, any nitrate, it's going to dissolve very, very nicely. It's notorious for being soluble. This is going to be an easy formula if you know that nitrate is NO3 and just write it as AgNO3. So if you're going to write a reaction, we would have our sodium sulfide and our silver nitrate involved in the reaction. Now, the silver sulfide, that's our other thing that we have to deal with. Again, we know the silver and we know the sulfide, so by now, writing that formula is going to be easy. The +1, -2, the same system, Ag2S. And what's special about this is we get a solid, and this is going to be really, really critical. I'm going to show you a quick way of doing a net ionic equation once you know about these. The real quick way is if you know what the precipitate is, the thing that doesn't have the sodium, that doesn't have the nitrate or potassium or ammonium, then you can figure out what the formula of the precipitate is and go backwards. Here I've written the formula. Silver sulfide solid. In the net ionic reaction, you're going to have one product. That's the silver sulfide. That makes things simple. If you can find the solid, if you can say, okay, which substance doesn't have a sodium or a nitrate in it, then you've got the net ionic equation set up right. So show the product. And of course, this product is made by these 2 ions. So you say, okay, it's got a sulfide ion. Now, I've written down aqueous to tell you that this is in solution. And, of course, what else makes up this sulfide? The silver. So you'd say the silver ions and the sulfide ions. Net ionic equation, you've got an ion. You've got 2 parts, cation and anion. Break it up, and don't forget the subscripts. This is 2 silvers. We needed 2 of them to make this silver sulfide, so you put this aqueous in. So the fast way of doing a net ionic equation, find the formula of the precipitate. Then break it up. Now this is the ideal way of writing the net ionic equation. On the AP exam, you don't have to put the phases. You don't have to put down aqueous, or solid. In fact, I would recommend not putting them down so you don't have a chance of making a mistake. This is the ideal, but you could just have 2Ag plus 1S with a -2 and Ag2S. Now, you have to have the charges here, and you have to have the coefficients. That's what the graders are looking for. On WebAssign, we don't use superscripts and subscripts because they're too messy. We just want to do it very simply. So we use the parentheses method where you would say, okay, I'm just going to have 2 silver ions. I put the ion charge in parentheses, so you know that it's a charge. And then 1 sulfide to make silver sulfide. Now, let me get to the molecular equation where we show everything that's happening. Now, this is nice because you can look at it and say, okay, this is the only thing that's happening. I mean, when you saw the video of the silver sulfide forming, that's what was happening. Silver ions snapping together with sulfide ions to make that muddy silver sulfide. For the molecular equation, you write the 2 substances that are involved. I'm going to put the silver nitrate first because I like silver. There's the silver nitrate. And we're going to add to it the sodium sulfide. There's our silver nitrate and our sodium sulfide. This is the reaction. Sodium sulfide solution reacting with silver nitrate. As all of our
Metathesis reactions.
we swap the ions. The silver goes to the sulfur, and the sodium goes to the nitrate. So our arrow is going to say these ions switch spots. So now instead of having silver nitrate, we have silver sulfide. And instead of having sodium sulfide, we have sodium nitrate. Notice how they switched places? Silver is still here, sodium is still here, but the sulfur and nitrate have switched. We know there's something wrong here because it's not balanced. We see we have 2 sodiums, and we see we have 1 nitrate and 2 silvers. So to balance this, you're going to have to put that 2 in front of the silver nitrate. Because you have 2 silvers as a product, you will need 2 silvers or in this case, silver nitrates because they're together. You're forced to put the nitrate as being a 2 there also because you start out when you bought it, you bought 1 silver and 1 nitrate for that $1,000. And I put down the aqueous, and again in a AP exam you wouldn't have to write that down, but we have our sodiums, and we'll end up only needing 1 of them because we see we had just 1 sulfur, so we just need 1 sodium sulfide. Arrow time. Now we still have our Ag2S. We have 2 silvers. That's good. And 1 sulfur. Let me check. 1 sulfur, 2 silvers, 2 silvers. Sodium nitrate. Well, we see we have 2 nitrates and we have 2 sodiums. And the formula for sodium nitrate is going to be Na plus, NO3 minus, 1 to 1. So we have our formula, which is sodium nitrate that we've shown here, and we need 2 of them because of this coefficient of 2 and because of this subscript of 2. This is the molecular equation. It shows you everything that's happening, but it also includes the spectator ions. Notice the sodium and the nitrate were aqueous, and they are still aqueous. They didn't change. So the only thing that changed was the silver and the sulfide, which were aqueous, and now they're solid. So here we have it. We have how to write the molecular equation, which is a little bit more complicated, and how to write the net ionic equation, which is the one that's usually asked for on an AP exam. So let's look at the reaction, and now we realize and see what's happening. The silver ions and the sulfide ions coming together to make silver sulfide.